Right. So I'll just start the lesson today. So when you think of linear motion, it is the motion along a line, simply just a line, right? In a straight line actually. So in that case, I think you refer the PDF I sent you earlier, right? So that PDF contains, I'm not going to give you that note again. I'll give you a short note in the class, right? So so in that PDF, you can check that if you want. There's displacement and distance. So we know displacement is the shortest distance between 2 points. So that is the displacement. So if I want to go from here to here, there can be many paths to go from A to B. But we only choose shortest path. So this is the shortest path. So you can clearly see that there is a certain direction for that. Other paths do not have a certain direction, but shortest path has a certain direction. Meaning, if this has obviously everything has a magnitude, this has a direction as well. So displacement has a direction and a magnitude, so it is considered a vector, right? So in this unit we are talking about vectors mainly, right? We are talking about vectors mainly. I'll just briefly explain the theory parts. You don't have to take anything down. In the PDF, everything is there, right? I'll only give you a short note on this, right? Right. So that is the displacement. Displacement is shortest path between 2 points. So that has a certain direction. Understood? Right. So once we define displacement, you can think about rate of change of displacement. In order to find, so displacement is denoted as S. So rate of change of displacement means change of displacement divided by time. So you can define velocity. So this is similar to speed, but velocity is a vector because it has a direction as well, right? So if anything has a direction, a physical quantity with a direction always is a vector, right? So to practice clearly what displacement is, first try the first question in the tute. And regarding, and if you want to try the question in the tute and send me the answer. Regarding those answers, I can see whether you have understood that or not. First question. It doesn't matter you get the correct wrong answer or not. I need you to understand. I need to check whether you understand this correctly. Please try first one, everyone, right? Send me the answer in the chat box. Send me the answer in the chat box, right? Carefully read the question first. I suggest all of you use the chat box, right? Okay, so what they ask is a correct sentence about distance. A, distance cannot be negative. I think everyone got the tute, right? Tute is in the group. Please download the tute, right? It is in the group. Right. First one, distance cannot be negative. It is true, right? Why? Distance cannot be negative because it doesn't have a direction. It only has a magnitude. It only has a magnitude. So A is correct. Distance cannot be negative. But displacement can be negative. A is correct, right? We don't, for an example, mass is a scalar, meaning it only has a magnitude. We don't say minus 1 kilogram, minus 2 kilogram, like that. So is distance. We don't say minus 2 meters, minus 2 kilometers, like that. So distance cannot be negative. It is true. B, distance cannot be zero. So if you remain at the same place, distance is 0, right? If you don't move, distance is 0. So cannot be 0 is wrong. Then C, distance traveled does not decrease with time. What about that? Distance traveled cannot be decreased with time. Yes. So let's say you start from here. Usually we call this point origin, right? Origin. So if you start moving to this side and comes back, so how much is the distance you moved from here to here? So you always have to add up. That's the distance. This distance plus this distance. So let's say A and this distance B. So the distance is A plus B. But the displacement is this one. Why? This is the initial position, this is the final position. This is the initial position, this is the final position. So this is A minus B, right? So the displacement has decreased. The question PDF is in the group, right? PDF is in the group, right? Distance traveled does not decrease. Distance traveled does not decrease. Yeah, distance does not decrease, distance only adds up. But the displacement can decrease. So as you are moving towards the origin, displacement decreases. And if you move behind the origin, displacement becomes negative. Displacement becomes negative. Then D, so C is it correct? Distance traveled does not decrease with time. Yeah, C is correct. What about D? Distance cannot be less than displacement. Yes, displacement is always larger because distance only adds up, right? Only displacement decreases. I think everyone got that, right? So D is correct. So the correct answer is, fourth one is the correct answer. Okay, fourth one is the correct answer. Right. So from that question, I think everyone has a understanding. Yeah, displacement can be negative, right? So if you start here and moves here and comes behind here, so the positive direction this side, if you comes behind origin, then the displacement at here is negative. So displacement can be negative. Now the shortest path is this path, right? So it is negative now. But distance cannot be negative because it only has a magnitude. We don't consider the direction there. You don't have to take anything down, right? Till I am saying, right? So we have this equation, U equals displacement divided by time. This equation only can be applied for constant velocity. You can, to find constant velocity, you can simply divide displacement by time. Given that this velocity is constant. So here you can have this form as well, right? This is only for constant velocity, right? Then you have another equation for average velocity. So that is the average value of velocity. For average velocity, you have to divide total displacement by time. Total displacement by total time. You can find the average velocity. Just take these two. Just take these two, and if you have any problems, send me. So this is only applicable for constant velocity, or we call this uniform velocity. Yeah, I'll explain that how to find the average velocity as we are doing a question. Okay. At the second question, it is 1/3. So these distances are same, 1/3. So the first part 10 meters per second, second part 20 meters per second, third part 60 meters per second. So the average velocity should be what? Total displacement is 3s divided by s divided by 10. This time is displacement divided by velocity. Another part s divided by 20. Another part s divided by 60. Then you can take s out. SS cancels off. SS cancels off. So here the common denominator is 60. So you get 6 plus 3 plus 1. Then 60 goes up. Then 3 divided by 10. Yeah. So the answer is 18 meters per second in order to find average velocity. So you can see this is the average velocity, total displacement divided by total time. Total displacement divided by total time. But within each range, it is a constant velocity. Within each range, it is a constant velocity. Okay. So the answer should be fourth one. Right. Then try third question. Third question. Draw a sketch, right? Draw a sketch first. So that question also using constant velocity, okay? Still we didn't start on acceleration. Still we are talking about constant velocity questions, okay? So we have two cars. One is A, another one is B. You can draw a sketch if it is not clear. So both starts at the same place. Car A has this velocity 50 kilometers per hour. Car B has 60 kilometers per hour. But car B starts after 1 hour. Car B starts moving after 1 hour. So both are car A has already started moving. After a while B starts to move. Since the speed of B is higher, B can pass car A somewhere here. But it started moving after 1 hour, right? So we need to build a connection between these car A and car B. Okay. If someone gets the answer, please send that. Send that in the chat box. Okay. So you have to build an equation. You have to build an equation between A and B. So you know displacement as car B passes B, car A passes B, distance traveled by A is equal to distance traveled by B. So that is the connection between those two. So SA, what is SA? Let's say this car A moves a distance. No, car B takes a simple t amount of time. Car A is already moving. If this is t time, car A has been moving for t plus 1. Okay, t plus 1. Because this is moving a longer time, right? It is already moving before. Then just apply S equals ut here. Because these are constant velocity equations, you can apply S equals ut for both. So what is SA? U is 50, time is t plus 1. Here U is 60, time is just t. Okay. So when you have this equation, you can divide both sides by 10. Get rid of everything. So as you are doing simplifications, you need to get rid of everything. Don't keep even a small thing, right? If you can cut it, right? So here what you get is 5t plus 1 equals 60. 5t plus 5 equals 60. 5t goes to the other side, minus 5t. So this becomes t. So t equals 5 hours. So what's the answer? Is it 5 hours or 4 hours? In the question they ask time required for car B to pass car A. So that time is simple t, right? Car B takes this much of a time. So the answer should be t. Then t is equal to 5 hours. Not 6 hours, right? 6 hours is the time required for the car A. Yeah, using relative motion, you can do this easily, more easily than this. Using relative motion, I will explain those later, right? Okay. So I think now you have a clear understanding of how to use uniform questions with uniform velocities, right? So you just have to apply S equals ut to those questions. S equals ut to those types of questions. But whenever there is acceleration, you always have to refer those motion equations. So we have 4 motion equations. So what are the 4 motion equations? So only requirement to apply motion equations is this one. Constant acceleration. So whenever something has a constant acceleration, you can apply these 4 equations, right? So the first equation is v equals u plus at. This is final velocity equals initial plus acceleration times time. Another one, you can take this down, right? U plus v divided by 2 times time. Another one, v squared equals u squared plus 2as. Just take this down. Another one, s equals ut plus half at squared. S equals ut plus half at squared. So only requirement is having a constant acceleration, right? You can apply these equations, these 4 equations. Okay, the questions after that is regarding constant acceleration equations, right? So you have to apply one of these. So you need to have the practice as you apply these equations. So you have to do a lot of problems using these. That will be useful later as well, right? As you are doing a projectile motion as well. Just try 4th one. Who can do that? Just try 4th question. As you are reading the question, just draw a sketch, right? If an object at rest so one arrow meaning velocity. Okay, you know that. Denote velocity using a one arrow. At rest meaning 0. Starts moving at acceleration 2 arrows. 2 meters per square second. Then it gains this velocity. 1 arrow. Practice those, right? As you are drawing sketches. So we have 36 kilometers per hour. What they ask is distance traveled. They ask distance in the question it should be distance, time and distance, right? They ask time and distance traveled in order to make this. So you can see this is not in meters per second. So everything should be in meters per second if there are different types of units, right? This is in kilometers per hour. So you have to remember how to convert kilometers per hour into a meters per second. How do you do that? You have to remember this, right? Yes. You just have to multiply this by 5 over 18. You have to remember this, 5 over 18. So 18 means 1, 36, 18 has 2 18s, 2 times 5. So that is 10 meters per second. So the speed gained is 10 meters per second. It is the final velocity. This is the initial velocity. This is the final velocity. And this is the acceleration. Okay, so first we need to find, first we need to find time. Let's find time. So you know, final velocities, you know, initial, you know, acceleration, you know, then you can find time. Okay, final velocity is 10 meters per second, right? Initial velocity 0 plus acceleration 2 meters per square second time t. So 10 equals 2t, then divide both sides by 2. 10 divided by 2 is what? 5, right? So you don't have to apply units while you are simplifying. You don't have to apply units. In chemistry you have to apply units, but physics you don't have to. But for the final answer you must apply units, right? Otherwise they won't give you any marks. You must apply units for the final answer. Okay, so time is just 5 seconds. Then to find displacement, you can apply any of this equation, or else you can apply S equals ut plus half at squared. Okay, so initial velocity 0, final velocity is 10, right? Divided by 2, time is we just found time, that is 5. So it is 25 meters. So the answer should be fourth one. So this is a simple question, right? This is a simple question. You just have to do the substitutions there. Okay, then try fifth question, and if you have any problems, please send me there, right? If I'm going too fast, please tell me. Try fifth question. Try fifth question. You cannot apply you cannot apply S equals ut here, right? You have to apply S equals ut plus half at squared, because this has I mean previous question I think you are asking about. So you need to apply half at squared. Okay, you cannot apply S equals ut. That is only for constant velocities, right? Okay, so initially airplane is at rest. So this is the length of the runaway. So always there's a runaway in the airplane. It cannot suddenly gain the required velocity. So in order to lift off, it has to move a certain distance at a certain acceleration, right? So here what they ask is, in order to have this much velocity after this displacement, what should be the acceleration? So if you carefully observe those equations, in this question the time is not involved. Time is not involved, right? So the only equation that doesn't have time variable is this equation, right? So you can use this equation. Okay, so final velocity 50 squared, initial velocity 0 plus 2 times acceleration a, displacement is 500. So 50 squared means 5 squared 25, 25 times 100, right? So 2500 equals 2 times 500, 1000, 1000 a. Just divide both sides by 1000. So you can have 2.5 meters per square second. Yeah, correct. 2.5. Third one is the correct answer. Just ask me if you, even if you have problems in these simplifications as well, right? You have to clear all the doubts. Okay. So the answer is 2.5 meters per square second. Okay. Then try a seventh question. First draw is sketch, okay? Just use 1 arrows and 2 arrows to denote accelerations and velocities. You need to clearly draw a sketch first, then try the question. So they ask final velocity v after 2 minutes. 1 minute means 60 seconds, right? I think everyone knows that. 1 minute means 60 seconds. 2 minutes should be 120 seconds, right? You need to convert that into seconds because this is in seconds. So what's the velocity? Time is there, acceleration is there, initial velocity given. So obviously this equation, right? Initial velocity 0, acceleration 0.5. What is 0.5? 0.5 is half, right? Use this. Time is 120. So cancel this one, you get 60. Follow these simplifications methods as well, right? So whenever you get 0.5, always substitute half, right? Whenever you see 0.5, don't just write 0.5. Put it as 1 over 2. It will simplify the, it will make the calculation simpler. If you see this one, 0.25, instead of this, you can use this 1 over 4. You have to use this if you want to save time, right? Another one, 0.75. You can use this one. So simplifying fractions is easier. Okay. All right. So velocity is this one. Then the distance travel, half at squared. Initial velocity is 0, so ut gets cancelled off. Half acceleration is 0.5. I'll put 1 over 2 instead of that. These are simple ones, right? But it makes a significant difference in calculations. Okay. Okay, so time is 120. 120 squared actually. This is 1/4. If it is too difficult, you can just write 120 squared like this. Then divide one of those by 4. So you get 30 there. So 3 times 12 is 36. There's a 0, there's a 0. 2 zeros. You could have simplified that in another way as well. But you can always factor these and divide. For this question, it is not that valid, but whenever you get a complicated calculation, always try to simplify that first before jumping into the calculation directly. Always try to simplify in that. So in the A-level exam, there's always going to be such calculations. So if you keep calculating from this end to other end, it will be much complicated, right? But if you see a pattern there, there's always a pattern in almost all the questions in exam, A-level exam, right? There's a certain pattern. You need to recognize those patterns in order to save time as you are doing simplifications. Okay. So while I'm doing these questions, just try to mimic those calculations. Okay. Okay, that question is done, I think. Then try a 88 question and tell me the answer. Yeah, you can use u plus v divided by 2 times t as well, right? Yeah, you can do that. I think in that case, it is much simpler compared to this one, right? A bit simple. Okay, try the 8th question and send me the answer. So there's a car, 45 meters per second, and then it has a 30 meters per second. Under deceleration, right? Deceleration means it is losing its velocity at a constant rate. So deceleration can denote like this, 2 arrows to the opposite side. Deceleration is not given. But this happens within 10 seconds, right? This decrease of velocity happens within 10 seconds. So what they ask is, so if it keeps the same deceleration, so obviously this car is going to stop somewhere here. What they ask is, after this one, how much time would it spend before stopping? So this t is what they ask. Yeah, 30. Initial velocity is 30 there. Then 15. Then velocity from 30 to 15, velocity decreases from 30 to 15. Then this is deceleration, right? Finally, it stops here. So the first thing is you need to find this deceleration. Without finding that, you cannot find this time, because same deceleration is here and here. So how do you find this deceleration? Just apply. So there are two parts to this question. One part, two part. So from 1 to 2, within this range, I'll apply this equation. Final velocity here is 15, right? Yeah, 15, yeah, not 45. Final velocity is 15. Final means within this range, final velocity is 15. Initial velocity is 30 plus acceleration times time. Time is 10 seconds from here to here. Then if you get it, this becomes minus 30 plus 15, it is minus 15, equals 10a. When you divide by 10 both sides, you get a negative value there. What does it mean? Negative value means this is a deceleration, right? That's why you got a negative value there. So here also you have the same deceleration. In order to find this time, just apply the same equation here as well, from 2 to 3. I'm applying this equation to this side. Final velocity 0. Initial velocity, within this range, initial velocity is 15, right? Since it is a deceleration, it is a minus 1.5 times t. So this minus 1.5 t goes to the other side. Plus 1.5 t equals 15. If you want, you can write this 1.5 as a fraction. What is 1.5? It is not going to make that much of a difference, but let's practice that. So 1.5 is, you can write it as 3 over 2. 3 divided by 2 is 1.5. Okay. In some cases, writing this fraction makes it way more simpler, right? So always practice this, writing these as fractions. Okay. Here it doesn't make that much of a difference. So instead of 1.5, you can write 3 over 2 equals 15. So cut both sides, divide both sides by 3. So you get 5 here, 2 times 5. Then you get 10. So it is 10 seconds. Yeah, time is 10 seconds. So the answer should be second one, right? Those who couldn't take it, you can take it down. And then try a ninth question. It is a similar question, right? It is a similar question. Please send me the answer. It is a similar question. It is easy. Ninth question. You have to follow the same path. Only these speeds are different, right? So here the speed is 45. Then it decreases to 30. It has a deceleration is given there. 1 meters per square second. Deceleration is given there, but not the answer, not the time. Okay, try that one. Everyone, right? Has a speed 45 meters per second. It decreases to 30 meters per second. And the deceleration is 1 meters per square second. It is to the other side. This is position 1, 2, then here 3. This range also, it has this deceleration, 1 meters per square second. So what they ask is this time from here to here. That time is what they ask. So here the final velocity should be 0, right? It stops there. Just apply from 2 to 3. V equals u plus at. So final velocity is 0. Initial velocity 30. Acceleration, it is a deceleration. So I'm applying minus here. Minus 1 times time. Yeah, time is 30 seconds. Actually, you don't need this part, right? You only need this part. Everything is given there. Right. Question number is 9th, right? 9th question. Try 14th question. 14th question, it is about, now the questions gets a bit complicated, right? Try 14th question. 14th question. Draw a sketch first. You have to know what reaction time is. I'll explain, just try that. 14th question. Okay, so listen now, right? Reaction time of a driver. Reaction time of a driver, what is that? So whenever a driver sees a barrier in front of him, when a driver sees a barrier, he applies brake. But it takes time, right? He needs to see that through his eye. With his eyes, he needs to see the barrier. Then that signal is traveled to the brain. Then brain gives a response to the leg and he pedals the brakes. That takes some time, right? It doesn't happen instantly. It takes some time. That signal goes through the brain and the brain sends a signal to the leg. That takes some time. So that time is what we call reaction time. So within the reaction time, brakes are not applied. Still the signals are sending, right? Within the reaction time, brakes are not applied. So still he is moving towards the barrier within the reaction time. So reaction time is, they say, 0.5. So he has a speed 20 meters per second. So within this, with this speed, he moves for another 0.5 seconds. So this is reaction time. He still is having a constant velocity. He's still having a constant velocity, right? Because brakes are not applied yet. So once the reaction time finishes, then the brakes applied, so is the deceleration. So then the deceleration becomes 5. Then after that, so here also velocity is 20 still. Then the velocity decreases. Then the velocity becomes 0. Finally, it stops right at this barrier. So to prevent the accident, barely prevent the accident, what should be the distance? The distance traveled within the reaction time plus distance traveled decelerating. So you need to find both of these. So here it is a constant velocity within the reaction time. Just find that. Apply ut, right? Velocity is 20, time is 0.5. So 0.5 means half. So this is 10 meters. So he's moving at 10 meters there. Then find S2. So to find S2, you can use this equation, ut plus Or else, since you don't know the time, this time you don't know. From here to here you don't know time. So this is the equation without any time. V squared u squared. Final velocity. So this is from 2 to 3, right? Final velocity is 0. Initial velocity 20 squared plus 2 times. This is a deceleration. So you have to substitute negative value times s. So this is minus 10s. Minus 10s. Take it to the other side, it becomes 10s equals 400. Then s is equal to 40. This is s2 actually. In order to prevent the accident, you need to prevent both. You need to add these both, right? Not just a one. So it is not 40 meters. This also should be added to that. Why? Within the reaction time also he is moving towards the barrier. So answer should be 50. 10 plus 40. Okay. So within the reaction time, brakes are not applied. After the reaction time, brakes are applied. Okay. But still he is moving towards the barrier within the reaction time as well. So that's about reaction time. So that is a important concept you have to understand. Okay, then try just take it down. Just take it down. If you are taking it down, okay, sure. Okay. So for this question there are two parts, right? So the driver sees the barrier. Driver sees the barrier, then applies brakes. He cannot apply brakes instantly. No one can apply brakes instantly by looking at a barrier. What happens? As he sees the barrier, that signal goes to the brain, and brain signals to the leg. It takes time, right? That time is what we call reaction time. So that time is 0.5 seconds. So within this time, there's no response. Within 0.5 seconds, there's no response. Right? No response there. That's why still the vehicle is moving at constant velocity. Because no brakes are applied yet. Okay. After the reaction time, once the signals are sent, it is completely finished sending signals. Now the brakes is applied. Here brakes are applied. Then it gains a deceleration. After applying brakes, it gains a deceleration. This deceleration. So this is a two-part question, right? So the total distance should be the distance traveled at constant velocity within the reaction time and distance traveled decelerating. So for this part, you applied s equals ut because it has constant velocity. Then from here to here, you apply this equation in order to find s. Got it? And if you have problems, tell me. Did you understand that? Try 13th question. Previous one, right? 13th, right? Draw a sketch. So there's a bus, then there's a car, but the car is 100 meters behind. I'll draw in two parts, right? 100 meters behind the bus. They both starts moving simultaneously. At the same moment, they start moving. The bus is in front, right? What are the speeds? Both have zero velocity, but their decelerations are different, right? Initial velocity is 0 for both. Car has this acceleration, that is 6 meters per square second. Bus has 4 meters per square second. Even though the car is here, since its acceleration is higher, the car has the ability to pass the bus. Passing something means at the passing point, both should be at the same place. Let's say it is here. When the time is t, This is happening simultaneously, right? Unlike the previous question, this is simultaneous. Happens within the same time, that is t. It is not t plus 1, like not like that, right? So you need to have a connection between car and the bus. I'm going to think about displacements, right? Okay, let's say SC is distance traveled by the car. It is from here to here. It is equal to what? Displacement traveled by bus. How can you make it equal? You have to add 100 meters to the bus. Then you can put an equal sign here. 100 meters. Understood? Car is from here to here. Bus is from here to here. If you add 100 to bus, then both become same. So we can build the equation, right? So that is this equation. Okay, then just apply a SCSB, then but you cannot apply UT here, right? You need to apply half AT squared as well because it has acceleration. So for both bus and the car, you can cancel this term because initial velocity is 0. You only need this part. S equals half AT squared. Right. Let's apply for SC for the car. Half A means acceleration of car, that is 6. Time we don't know, t squared. Then for SB, it is half, acceleration is 4, t squared plus 100. So this is 3t squared, 2 squared. So 3t squared equals 2t squared plus 100. So 2t squared comes to the other side. 3t squared minus 2t squared, 1t squared, right? If you want, I can write that. 3t squared minus 2t squared equals 100. 3 minus 2, that is t, 1t squared equals 100. Take the square root of both sides. So it should be 10 seconds. 10 seconds, yeah, correct. Fourth one is the answer. If you have any problems, please send me, right? Even the problems with calculations, because I need you all to go in a same phase, right? If you have any problems on these, you can even ask me later privately, right? If you have any problems on these, I need everyone to go at a kind of like a approximately a same phase, okay? If you got this down, then try 16th question. It also has an important concept, that's why try 16th. I think everyone taken this down, right? No, for constant acceleration you cannot use S over UT. You can use that only for constant velocity, right? If there's any acceleration, you need to use full form of those four equations. You cannot apply U over T, right? Not U over T, actually, it should be UT, right? S equals UT. You cannot apply it here. You need half AT squared, okay? If someone got the answer, please send me. So this has a very important concept, right? Now listen, this has a very important concept. You need to understand within and after. Those are two terms, right? One term is within, another term is after. So if they say after 5 seconds, after 5 seconds means from initial point to the end point, from here to here, that is after 5 seconds, right? If they say within 5th second, what is 5th second? It is this one, right? From this moment to this moment, from 4th second moment to 5th second moment, right? So what do you say, like first second, within first second means from t equals 0 to t equals 1. This happened within the first second. First second means within, from 0 to 1. So just a 1 before that, right? So if they say 100 second, within 100 second, what should it be? 100, 99. So within 100 means this one. So within 5th second, in the question, within 5th second, it says he moves a distance 90 meters. So this distance is 90 meters, not distance from here to here. Within this second, it is 90 meters. That's what it means. And it has a constant acceleration. So what do you? So I'm going to apply equations from here to here and from here to here. For the first one, let's say that is S1. Distance from here to here is S1. Distance from here to here is S2. I need to involve this 90 meters, right? That's why I do that. So how can it, 90 meters is equal to what? S1 minus S2. S1 minus S2 equals to 90 meters. Now I have an equation. There's this equation. So S1 is from here to here. You can see initial velocity is 0 in both cases. Initial velocity is 0. So when you think about this equation, you can neglect ut part because initial velocity is 0 there. So the equation becomes just half at squared. Understood? Because initial velocity is 0. Right. Then S1. What is S1? Half acceleration we don't know. That is A, right? Acceleration is simple A. For S1, time is what? For S1 from here to here, that is 5 seconds. Half at squared minus for S2 from here to here, it is 4 seconds. 4 means the moment, 4th second moment, right? Half A, acceleration same for both, 4 squared equals 90. So this has 5 squared is 25, 25A divided by 2 minus 16A, 4 squared A divided by 2 equals 90. So what is this? Common denominator is 2. Common denominator is 2. So then 25 minus 16, that is 9, right? 25 minus 16 is 9. There's a simple A here. 90. Then 9 divide both sides by 9. Then you get 10 here. Then cross multiply. So acceleration becomes 20 meters per square second. 2 times 10. 20 meters per square second. What do they ask? What they ask is velocity here. Final velocity at the 5th second. After 5th second. Since we found the acceleration and we know the time, just apply equations from here to here. This is the equation, right? U plus 80. Here velocity is 0, initial velocity. Acceleration is, we found that 20. So the time is 5. So it should be 100 meters per second. Should be 100 meters per second. That's the 4th answer, right? You can take it down. Then I'll talk about motion under gravity, right? Write down the topic motion under gravity. Motion under gravity, right? So if I throw this upwards while it is moving up, its motion, it is only force applied on this is its weight while it is moving upwards, right? While it is moving upwards, only force applied on it is its weight, meaning it only has gravity affecting that. There's no any other force. There can be air resistance, but we neglect that in this part, right? We only consider weight of those objects. So weight causes to have a gravitational acceleration on those objects. So in the syllabus, that gravitational acceleration is always downwards and it is 10 meters per square second. What does this mean? To be precise, it is around 9.81 meters per square second, but always it is averaged. Averaged, it is 10 meters per square second downwards. Okay, no, it is for the question, I'm referring to the previous question. It is 5 seconds, right? Not 6 seconds. I'll explain that. Can you send me a message later, right? I'll explain that if you don't get it. Now focus on this. So this is 10 meters per square second downwards. What does this mean? So what meaning of that is, when an object moves upwards, at every second it loses 10 meters per second. So let's say you project an object at 100 meters per second. At the next second, it decreases its speed by 10 meters per second. So next second it is 90 meters per second. At the next, 80 meters per second. Likewise, as it moves up till its velocity becomes 0, so it takes like 10 seconds till its velocity becomes 0, right? Then its speed decreases. To upward, speed decreases. Downwards, it is like force is downwards, right? To downwards, speed is increasing. At every second, speed is increasing by 10 meters per second. 10 meters, another 20, 30, 40. Likewise, speed increases downwards. So that is what this means, right? So this is not what I want to say. I think everyone knows this part, right? There's a sign convention to this. Many students mistake directions, confuses with directions for motion under gravity. So let's say you throw an object upwards at U. This point is called origin, right? Origin is where any motion starts. Then from the origin, it throws upwards. Then its velocity becomes 0 here. Then falls back. Again, the velocity is the same. As it hits the ground, velocity is same. So whenever you define a motion, you always have to define an origin where you start the motion and a positive direction. What does this mean? What is positive direction means? Any vector to that direction is positive. If anything is to opposite direction, negative, right? So that is what it means. So I'll say this point A and B. So these are the common equations that we are going to use for this one. So first one, I'll need to find the time to reach the maximum height. Let's say maximum height is capital H. So you can apply this equation from O to A. So what's the final velocity? From O to A, final velocity is 0, right? Initial velocity is U. What's the sign of G? Sign of G? Yeah, it will decrease exactly 10 meters per second. For this level, it is enough, right? Yeah. It is minus G. Okay. Because, see this vector is downwards. I am considering upwards as the positive direction. So this is minus. Then time is T O A. Take this to the other side, G T O A equals U. Then divide by G. Okay, this is the time to reach the maximum height. U divided by G. Got it? So whenever they ask, you need to follow this one. You don't have to remember this, right? You just have to follow this. Right. Okay, first take all this down. Just take it down. Take all this down, and once you've taken it down, thumbs up, right? For this level, it is enough to know it decreases by 10 meters per second every second, right? In reality, that does not happen, but approximately it is the case, right? So when you are learning gravitational field, you will understand that G changes. It is only for that lesson. For all the other lessons, it is, this case is true. If you taken it down, thumbs up. Right. So what do we find? Time from here to here. Then another one called flying time, right? Flying time. Flying time means from here to here. when the object is always is air that time. So for that kind of question, this is the equation we use. So when we use an equation, it is very convenient if you can make some terms zero, right? So we need to find the flying time, meaning you have to apply this equation from here to here, from OA to B, from O to B actually. Then you get flying time, T. What's the displacement? Goes up, comes back to the initial position. Now the displacement is zero, right? It is back at the initial position, zero. Initial velocity is u. Let's say time t plus half. I'm applying this upwards, right? But the acceleration is downwards. So you have to substitute as a negative value, minus g. Take this minus whole term to the other side. It becomes half gt squared equals ut. Then cancel t from both sides. Cross multiply, 2u goes to the other side, then divide by g. So this is t equals 2u divided by g, right? So you can see it is, this time is twice this time, right? Meaning time to here, from here to here is equal to time to from A to B. All these details are in the PDF, right? So you don't have to take anything down, just refer the PDF, right? So this is TOB, this is 2u over g, okay? So this is what we call flying time actually, flying time. The reason we use this equation is because we could make S 0, okay? That is convenient. That's why we use that to find the flying time. What else do we need? We need to find this capital H, maximum height, this capital H. I'm using this equation from O to A because I need to find this maximum height. Final velocity 0, initial velocity u plus 2. Again I'm applying equation upwards, acceleration downwards, right? So it is minus g, height is capital H. Take this negative term to other side, becomes positive, equals u squared. Then h is equal to divided by 2g. So this is the expression for maximum height. You don't have to remember this, right? Just have a slight idea of how to quickly get the answer there. You can take it down as well. So that's the maximum height actually. Yeah, those stuff is what you need to find there. Taking it down, right? Okay, thumbs up. If you have taken it down, thumbs up. Okay, so this is the normally this is how we apply equations there, right? So another form is, so this object is projected upwards. Another form is you can drop an object like this. You can drop an object. I'll explain that using these questions, okay? Try 18th question. I'll explain that for those who can't understand that. That is for a dropped object. Releasing me also means dropping, right? Dropping means initial velocity is 0. When you release an object, initial velocity is 0 there. That's what releasing, dropping means. Okay, so try 18th question. You can draw a sketch first. Those who got the answer, you can send me. Actually, these are easy questions, right? If you got the answer, send me that. Okay. So what they ask is, if you drop this from a 3.2 meter height, and this is the acceleration, motion under gravity. What they ask is, what is the velocity it hits the ground? Okay. So we have distance, I mean displacement, acceleration, velocities. Time is not involved. So which equation should you use? Best one. Equation without time. This one, right? So final velocity v squared, initial velocity 0 plus 2 times acceleration 10. Why do we put plus 10 here? What's the reason? Yeah, plus 10. Because I'm applying the equation downwards. Yeah, I am applying the equation downwards, meaning I am considering positive direction to be downwards. You are free to choose any direction you want, right, to make the positive direction. But when you are substituting values, you have to make sure whether they are to the same direction or not. I'm applying this downwards, so it is plus. Positive direction is downwards now, right? For previous one, positive direction was upwards. I chose that, like here positive direction is downwards. Now this is 10, then S is 3.2. Then V squared equals 2 times 3.2, 6.4, else 10 times 3.2 is 32, 32 times 2, 64. Then we take the root of both sides, it becomes 64 root means 8 meters per second. Not per square second, per second, right? 8 meters per second. Then another one, they ask time, right? Now we know the velocity 8. We need time, this time from here to here. Just apply this equation. Final velocity 8, initial velocity 0. Acceleration, it is downwards. I'm applying equations downwards. So plus 10 here. Times time. So 8 equals 10t. Divide both sides by 10. So this becomes 0.8 seconds. Third answer. Answer is third one, right? Then try a 19th question. 19th. Draw a sketch. Draw a sketch, right? Don't just keep looking at the question. As you are reading the question, draw a sketch as well, right? So you don't have to look at the question again. Mention all the things in the sketch, right? So this object also is released. So initial velocity is 0. What they ask is after third second. Not within, right? It is after third second. What they ask is this velocity. Actually, this velocity, you don't have to do any calculations, right? This is t equals 0. After third second means after first second. What did I say? At every second, speed increases by 10 meters per second. After 1 second, 10. Then 20, 30. So we should be 30, right? I'll just apply equations u plus 80. Initial velocity 0, acceleration downwards plus 10 times time is 3. So it is 30 meters per second. Downwards 30 meters per second. Then you need to find this displacement. Yeah, correct. Apply this equation from here to here. Initial velocity u is 0. So this term cancels off. You only need half t squared. I am applying downwards, right? What's the meaning of this arrow? I'm applying the equation downwards. Positive direction is downwards. That's what it means. Half, acceleration 10. Time is 3. 3 squared. 3 squared 9. 9 times 10, 90. 90 divided by 2. So it is 45 meters. What's the answer? Yes. Answer is 30 and 45. Yeah, first one is the answer. Yeah, correct. Yeah, good. Then try a 20th question. Next one, 20th. That question had third second, right? Third second. What does third second means? Initial velocity 0. I told you third second means t equals 3 and 3 equals 2. This time period. Third second means 2 and 3 between. If you take 100 second, within 100 second, 99 and 100, between that 99 and 100. Correct? That's what it means. 100 second, 99 and 100. Here 2 and 3. Correct? Because first second means 0 and 1, right? 0 and 1. they ask this distance. How do we find this? I'll apply equations from here to here, from here to here, then from here to here. Let's say that is S2. S1 minus S2 is the distance traveled within the third second. Got it? Within the third second. S1 minus S2. So separately you have to find S1 and S2. So what is S1? Downwards. Initial velocity is 0, right? So there's no ut term there. Initial velocity is 0. So there is no ut term there. You only need half at squared. You only need half at squared. So half, acceleration is 10. It is downwards 10. Time is what? From here to here, time is 3. So 3 squared. 90 divided by 2, 45 meters. That is S1. Then S2. Meaning from here to here, S2. Then you need to find from here to here. S2, half at squared. Half, A is 10. T means from here to here, time is 2 actually. 2 squared. 4, that is 20 meters. 4 divided by 2, 2 times 10, 20. So what's the answer? S1 minus S2. S1 minus S2. 45 minus 20. So that is 25 meters. That is delta S. 25 meters. This is ball distance, right? 25 meter. And what is the acceleration? Everywhere acceleration is 10 meters per square second, right? That is the gravitational acceleration. Yeah, correct. Yeah. So it is 25 meters and 10 meters per square second. Third one, right? Just take it down. Then who taken it down? You can try 21st question. 21st question. It is a similar question. It just has symbols. Don't be afraid of those symbols, right? Just try that. It is a similar, right? Same concept. Don't put 10 there, right? Instead of 10, you can use simple G. Next question, 21. 21. So in this question, nth second, within the nth second, how do we do that? Nth second means n and n minus 1. 1 before that, right? Yeah. So you just have to do the same thing. G downwards. Get the from here to here. Let's say that is S1. Then from here to here, let's say S2. What should be the answer? S1 minus S2 should be this. That is the distance traveled within the nth second. Okay. So for this also, when you apply, this term cancels off because initial velocity is 0 for both cases. It is dropped, right? Right. So let's find S1 first. S1. Half G from here to here. This is nth second. Gn squared. That is S1. If you didn't get it, tell me, right? Half G n squared. Then S2. Half G from here to here. What is the time? N minus 1. N minus 1 squared. Now this is just a simple algebraic calculation. We need S1 minus S2. Half G n squared minus half G n minus 1 squared. So I have to simplify this. This is a one term. This is another term. So you can take half G out. So inside the brackets, n squared minus n minus 1 squared. Understood the calculation? When you take half G out from each term, what is remaining is n squared minus n minus 1 squared. Okay. Half G n squared minus. I'll expand this one. This is a plus b squared, right? I'm explaining these calculation steps as well, okay, because some students find somewhat so square root of this plus square root of another plus 2ab. So you have to do the same thing for n minus 1 squared. What do you get? N squared minus 2ab. 2 n times 1, that is n, minus 1 squared plus 1. Half g n squared minus n squared, then minus minus plus, minus times plus 1 minus 1. Half g 2n minus 1. Half g 2n minus 1. Okay. So what's the answer? Answer is fourth one. Okay. Answer is fourth one. You can take it down. You can take it down. So from the class, as I can see, the students are like in a kind of like a range. I need to bring all of them to like a one form, right? So it might take time. Like after this, I'll send you a quiz. That quiz contains similar questions actually, because I need you to practice this stuff. Okay, but that's the only solution for you. Like you have to practice again and again. That's the only way, right? The problem is having a lack of practice for those. So you are not like just memorizing stuff. So when you are doing again same thing again and again, you will understand that track. You will make into that track, right? So I'll give you a quiz. I'll give you a quiz on tomorrow actually. Then all of you have to submit that quiz, right? That quiz is only based on similar questions. I'm not trying to make it like more complicated. So I'm trying to go like by step, right? So this is a fundamental. So at the next class also, I'll discuss from linear motion, because I need you to have this foundation, how to apply a vector equation, right? So at the next class also, I'll explain in this one plus some projectile motion questions as well. But everyone has to do the that one, right? That quiz. You have to try that on your own. You can check. No, not today. You can. I'll give you the quiz on tomorrow, right? I'll give. You can submit. I'll give you a time frame, and then you can submit that there. You will have similar questions there, and if you have, I'll check whether everyone submits that, right? So everyone has to submit that. I'll personally check that, and if you have any problem, you can ask me, right? Okay. Yeah, because students, I can see that students are at like different phases even in this class. So like everyone has to comes to a kind of like a same phase, right? So it might take some time and dedication, but I need you. It is like that, right? So I'll explain the remaining questions on the next class. I have to complete this totally, right? Then I'll move on to projectile motion. So the next class will be on next week, same day, same time, right? And if you have any problems, you can privately ask me, right, individually, right? Then good night everyone. Thanks for, yeah, good night.